Are you a software developer or a .NET developer, or do you like working with Vim or NeoVim? Then this video is for you. Welcome to Handcrafted Code. I'm David, and in this video I'll walk you through setting up a .NET development environment in Helix on Ubuntu Linux. If you're a fan of Vim or NeoVim, Helix should feel instantly familiar. What makes Helix stand out is that it combines the speed and efficiency of modal editing with a modern batteries included experience, so you can stay focused on writing code instead of spending hours configuring your editor. For this video, I'm using a virtual machine running a fresh installation of Ubuntu Linux, so we'll be setting everything up completely from scratch. And don't worry, I'll include a link in the description to a gist with all the commands I run in this video, so you can copy and paste them yourself. Also, if you're using Windows or macOS, I've got you covered too. I'm recording videos for those platforms as well. Alright, let's get started with this setup. Alright, let's check if I've already have Git installed. Yep, Git is already installed. So now let's install the Helix editor. By the way, I need to use the mouse for pasting text because this virtual machine doesn't capture command V. So what I'm doing is I'm adding the repository for Helix. Now let me update the references. And now let's install Helix. Okay, now let's install the .NET SDK, the latest one as at the recording of this video. Oops. Okay, now it's time to set up OmniSharp. I normally use OmniSharp for managing the .NET applications through Helix. OmniSharp is what gives our editor C# superpowers. Helix is the editor, but OmniSharp is the tool running in the background that understands our .NET project. It provides features like code completion, diagnostics, code definition, and other language features you'd expect from a modern development environment. It's referred to as language server. And you have language servers for other programming languages such as ECMAScript, JavaScript, TypeScript, but also Lua or Java. So you can look into those as well if you want. So you'll find more information at www.omnisharp.net. Okay, so let's set up OmniSharp. First thing I'm going to do is I'm going to create a folder for the OmniSharp files and a folder for the user local executables. Now let's go into that folder. And let's check what CPU architecture we have. Uname-M. So in my case, I have ARC64, which is basically an ARM64. And the reason is because this virtual machine is hosted in a Mac computer, which is running the M4 chip. But in your case, you'll have most likely you'll have something like x86-64, I think, which is going to be the vast majority of you. Now I'm going to run some commands, just one command, which is specific to my architecture. But in the description, in the link in the description, you'll find the commands for the x86 architecture for your computer. All right, so let me download that specific file. Let me try again, but with double quotes around it. Okay. Alright, so now I need to extract the downloaded archive. And now I need to make the OmniSharp binary executable. Now I need to create a symlink. This is so that you can call OmniSharp from the terminal and also update OmniSharp without having to move the OmniSharp files out of their original folder. Otherwise, you will have to run OmniSharp using its full path every time, which is annoying, especially if you want to integrate it with other tools such as Helix. So let's do that symlink now. Now we need to make sure that the local bin folder is on the path. And we also need to make sure that this is on the path for ZSH shells. Now we need to update the path in the current shell immediately. And now we need to verify OmniSharp that it starts in the language server mode. So let me just test it here. Okay, so there's no errors. OmniSharp is just sitting there waiting for commands. So I'm going to stop it with Control-C. And now we need to create the Helix config folder if it doesn't exist already. And now I need to open the Helix language config file to add OmniSharp. So I'm going to use Helix for that. And I'm going to copy paste this code that I prepared earlier, this configuration. Close, save and close. And now we need to test the health, the server configuration health with this command. Okay, so Helix knows about OmniSharp, but it hasn't found the binary for the netcoredbg, the debug adapter. So let's fix that. We need to create a folder for the debugger files and a folder for the user local executables. So let's create that now. So yeah, don't worry, everything is in the gist file, so you'll be able to just copy all of these commands. Now we need to go into the debugger install folder. And now we need to download the Linux, in my case the ARM64 netcode debugger. I suspect I'm going to have the same problem here. Let me try. Yes, let me put double quotes around that. Let me try again. Okay. Now we need to extract the downloaded archive. And now we need to make the debugger binary executable. And now we need to create a shortcut in local bin so Helix can find it on the path. And now we need to make sure that that binary can also be executed. And now we need to add local bin to the path for bash. And also for ZSH. And let's update the path in the current shell session right now. And now we need to verify that the shell now finds the debugger. So let's test it out. Yep, okay, so it knows about it. Let's see if it runs. Yep. Now let's check the configuration health with Helix. Yep. So we have OmniSharp and we have the debug adapter. So now it knows about it. Cool. Now at this point we are pretty much ready to edit existing .NET applications, create applications, websites, and so on. ASP.NET websites. Let's just do a quick test. So let me see. I'm going to create. Let's go to the home folder. Let's create a new folder called repos. And inside that folder, I want to create another one called my console test. And I'm going to navigate into that folder. I'm going to open, let's create a new console project here. .NET new console. And now I'm going to open Helix at the current directory. Let's edit program.cs. I'm going to copy this file, this line. And I'm going to put some changes here. So at this stage, Helix is already aware of the API, aware of the libraries in .NET. If I have spelling mistakes or problems, it will complain. Let me just save that. It should complain. Okay, the reason it wasn't complaining was because I needed to close and reopen the terminal. Once I did that, then Helix started to work properly with .NET. So now if I open the program, you should see that it complains here. And if I press space and then A for perform code action, let's see what it suggests. Convert to raw string. Nah. What about the closing bracket? Okay, space A. Nah. Well, it's telling me that it's expecting a closing bracket, so let's just add it back in there. But we should have, let's say int test equals 0 to string. Yeah, okay. So now we have auto completion and syntax validation. All right, so let's save and close. .NET build, .NET run, and we have that. Now there is an experimental feature. Last time I tried it, it didn't work, but let's just try it again. I'm going to open a new terminal window here. New window. And then I'm going to go to my console. Let's go to the bin folder, debug, net. And this is where the files got built. So now let's go back to the other window, run Helix at the current directory, open program. Now what I want to do is set a breakpoint here. So put a breakpoint in here, then launch the debugger. So you can launch a new process or you can attach to an existing execution, an existing process. We are going to launch it. So now it's asking me where the DLL was. So I'm going to copy this path. I don't know if it's going to work. We'll see. It's experimental anyway, so. And then here, I'm going to do my console test.dll. Enter. Oh, yeah. Don't send. Show details. Nah, Okay, now still not working. But anyway, hopefully once they iron out this feature, this process is smoother. Okay, so let me delete that folder. Now, so you can edit code, console applications, ASP.NET websites, and so on. But what I want to do now is I want to build a game using a game development framework called Raylib. Raylib is like a code-focused or code-first game development set of tools written in C, but we have C# bindings for it. So let's set that up now. So the first thing I want to do is I want to install tools and Linux dependencies so that we can build Raylib from source. So I'm going to paste this command, which is going to install build essential, CMake, and some other libraries. Okay, now let's clone Raylib. Now let's go into the repo itself and let's configure a shared library build. Now let's actually build Raylib. Now let's install libraylib.so into the system library path. Now let's refresh Linux shared library code. Now let's confirm that the native Raylib library is now available. Okay, now we are ready to write the game. So let's create that folder. So let's go back up a folder. And then my Raylib game. Let's go into that folder. Now I'm going to create a new console project here. And now I need to add a NuGet package, which is Raylib-cs, which is the C# bindings for Raylib. So .NET new add Raylib-cs. Sorry, my bad. .NET add. Wait, what? Oh, is .NET package add. There we go. Raylib-cs. My bad. Okay. Now I'm going to copy paste some code that I prepared earlier. So let's go into Helix at the local directory. Let's open the program.cs and delete these files. I'm going to copy that. Save it. We don't have any syntax errors. Okay, let's exit and let's build and run. And .NET run. Okay, so that's the demo game. And that's it. Alright then, I hope you found this video useful. Take care, code well, and I'll see you in the next video.